What is addition reaction? We have already discussed in brief. So this is one molecule having a double bond. Any molecule having a double bond, that means full of electron cloud. This is even electron density. That means non-polar molecule. Non-polar molecule will have always even electron density. Double bond, pi bond. So this type of molecule whenever we have, then electrophilic addition will take place because electrophile can easily penetrate electron-rich species. This is electron-rich species, and that's why electrophile can penetrate over here quite easily. This position, double bond, it will break and it will be added up here. So first electrophile will be added and followed by the nucleophile. That is called electrophilic addition. Now these are electrophiles. Just they are in front of you. They are CH3 plus, Br plus, H plus. These are all electrophiles.
Is it Br plus?
Yeah, Br plus, Cl plus, I plus, all possible.
Yeah, minus.
No, there. It is called chloronium ion, bromonium ion, and iodonium ion. Okay, not chloride, bromide, iodide, but chloronium ion, bromonium ion, and iodonium ion. Cl plus, Br plus, I plus. Then only they can act as electrophile. Otherwise, they will become nucleophile. So here they are acting as electrophile. That's why they are plus. That is there. It is possible. How I can tell you? You have Br2, one Br plus, another Br minus. You have Cl2, Cl plus, Cl minus. That way it is broken into two parts. One is the positive part, another is negative part. Positive part is the ion, the cation, and the negative part is I, the anion. Bromide, chloride, iodide, anion, and bromonium ion, chloronium ion, iodinium ion, the cation. So both are happening by uneven that splitting. That is called heterolytic fission. Heterolytic fission. Okay, heterolytic fission means Br plus, Br minus, Cl plus, Cl minus. That way it is getting ionized. It is called heterolytic fission. And in that case, you get chloronium, bromonium ion as well as chloride, bromide. Okay, and it is acting. The electrophile is getting added up first. That's why we are getting electrophilic substitution, addition, electrophilic addition. First electrophile getting added, then followed by nucleophile. Now neutral nucleophiles are there. These are sometimes acting as carrier, like AlCl3, acting as a catalyst into Friedel-Crafts alkylation or acylation. Okay, these are not only electrophile, but they are called they are electron deficient species, and they are called Lewis acid. They are also Lewis acid. So electrophiles are Lewis acids. Okay, because they have vacant orbital, lack of electron density, positive charge maybe or neutral maybe. So like H plus, this is positive charge. Cl plus, they are positive charge. But you have neutral molecule also, they are acting as electrophile, neutral electrophile. Now, reaction with positive electrophile or neutral electrophile, that will happen here. Structure of alkenes is like this. Carbon, it is in the excited state we have tetracovalent structure. So 1 2s orbital and 3 p orbitals are involved, giving sp3 hybridization, and there are 4 bonds possible. But whenever sp2 hybridized state, it goes into the sp2 hybridized state, then there will be 3 2p or sp2 hybrid orbital and 1 will be pure p orbital. That is happening into our carbocation. sp2 hybrid orbital having 1 pure p orbital, and where it is happening? Carbocation. And sp3 always will have 4 bonds, sp3 hybrid orbital, 4 sp3 hybrid orbital, and for sp2 there are 3 sp2 hybrid orbital and 1 pure p orbital. Hey, yes. Why are you talking constantly? Don't. Now hydrogenation of alkene. How does it happen? Already I told you. Let me just recall once more. So there is a chemistry option. Suppose the surface of platinum or nickel there. Platinum or nickel surface there. Now, this just imagine these pins are hydrogen atom getting attached. How? First of all, the molecule is H2 molecule, and this H2 molecule is getting atomized, and in the atomic state getting attached to the nickel or platinum surface like this, hanging like this. Why? Because nickel or platinum on the surface there is a high energy there is called surface energy. And what is happening? Because the molecules on the surface, nickel or platinum molecules on the surface, instead of 4 bonds, they are making 3 bonds. And 1 bond they cannot make because outside there is no atom. So they can make bonds only with 3 other atoms, but the 4th one is empty. That bond could not be made. That's why making the surface highly energized. That is called surface energy. Oh, okay? Because it is dissatisfied, so energy will be high. If it is satisfied, low energy, stable. If it is not satisfied, so high energy, unstable. So nickel or platinum, tetracovalent. So they are making 3 bonds. Those who are on the surface, they cannot make 4 bonds because outside there is no atom. So those who are on the surface, they are dissatisfied and lot of energy accumulated on the surface. That is called surface energy. And that means it is like acting as a magnetic field, just like a magnetic field. It is electric field actually. Okay, electric or magnetic field both are there together. So it is attracting the other atoms, other molecules, whatever available. Suppose hydrogen gas is coming in contact, that will be attached by chemi-absorption principle. Getting attached like a chemi-absorption principle. So that is the technology or that mechanism behind the hydrogenation of alkene. That is the mechanism. First of all, hydrogen getting atomized in the form of H. But normally you don't find that atomization. So atomized state. So hydrogen getting atomized and in the atomic state, normally you don't find hydrogen in the atomic state because the energy required for this atomization is very high. Okay, so normally you don't find it. Atomic state of nitrogen, atomic state hydrogen, don't find normally. Okay, atomic state oxygen there, but atomic state nascent oxygen that you can generate. But nascent hydrogen here from the molecule itself is difficult because a lot of energy we require. Okay, so but it is happening here. Why? Because metal is making a bond with hydrogen. Metal making bond with hydrogen by chemi-absorption. Now, during hydrogenation, this atomic state hydrogen donated by the platinum or nickel surface to the alkene, giving you the final product alkane. That is the mechanism. It is happening for platinum or nickel, and palladium also acting as a catalyst, but there the mechanism may be different. This is called physisorption. Here it is chemisorption. For palladium, it is physisorption, means physical adsorption. Okay, what is the difference? Chemisorption means getting bonded on the surface. That is chemisorption. And physisorption means there are cuts and holes and seepage in the molecule. Molecule is penetrating inside the surface, getting inside, just like a sponge. Just like a sponge absorbing water. So here the gas is percolating inside into the holes and cracks through the surface, going to the bulb. But whenever you apply any sort of some sort of energy or something like heat or some other type of radiation, so that gas may come out. It may come out because it is already not bound, so easily it comes out. So a piece of palladium you put into hydrogen gas, lot of hydrogen will be sucked in. Okay, take the piece of this palladium with the soaked in hydrogen, just put into some hot container, the whole gas comes out. Okay, that means it can absorb so easily, it can dissolve also so easily. That is the mechanism for palladium. But for platinum nickel, is bonding. So that's why releasing from one side is happening, and you will get always cis hydrogenation. What is the meaning? Cis hydrogenation. That means both the hydrogen coming from the same side. Okay, could you follow? Cis hydrogenation. Both the hydrogens, so all the hydrogens are on the same surface, no? On the same plane. So one by one hydrogens are getting detached from the surface and getting available, going into the molecule. Which molecule? Alkene. So it is given to the alkene molecule. So one hydrogen is taken by the alkene molecule, the second one is also taken by the alkene molecule from the same side. It is called cis hydrogenation. So this mechanism for nickel and platinum is cis hydrogenation. Okay. Now Markovnikov's rule, addition reaction Markovnikov's rule, it will be applicable only when you have a asymmetric alkene. If you have a symmetric alkene, like only you take CH double bond CH3, you don't get any Markovnikov or anti-Markovnikov addition because it is both it is same, means it is symmetric. If you take asymmetric one, then only you understand, you will get the two different product according to Markovnikov or anti-Markovnikov addition rule. That is, for example, propene. If you take ethylene, don't get Markovnikov, anti-Markovnikov, because it is symmetric. But if you take propene, it is not symmetric. Example, CH3, CH double bond CH2. That is the molecular structure. Now, if the this HBr addition, you perform HBr addition, then first, where the bromine will go? It will become CH3, CHBr, CH3. That means bromine is going in the carbon number 2, not carbon number 1. It is going to carbon number 2. Okay, 2 bromo propane you are getting. From propene you are getting 2 bromo propane. That is called Markovnikov addition. On the other hand, you can get another product by other mechanism. We are getting CH3, CH2, CH2Br. That is called anti-Markovnikov product. But mechanism for both the cases are different. If you go for that ionization, ionic mechanism, then you are getting Markovnikov product. But if you go by radical mechanism, then anti-Markovnikov product. This ionic mechanism occurs in aqueous medium, strong polar medium. There ionic mechanism will occur. Why? Because in polar medium, HBr will give H plus plus Br minus, which is called heterolytic fission. Heterolytic fission. So that is happening. Heterolytic means uneven fission, and homolytic means equal fission. It is breaking into two equal parts. That is called, it is becoming even, so it is called homolytic. But you are getting two different one is cationic, another is anionic part, that is called heterolytic fission. So HBr here becoming H plus plus Br minus, then this molecule as electron rich, that's why Br minus cannot attack, so H plus will attack. So first it will, H plus will be added up, so making a carbocation over here at the carbon number 2, followed by Br minus addition. So that is the mechanism, and you are getting 2 bromo product, which is called Markovnikov product. On the other hand, if you give some radical, and obviously the mechanism here will be radical mechanism, and the solvent here will be non-polar solvent. So if you use non-polar solvent, then this ROOR in presence of sunlight or heat will break into RO dot. That is called initiator. So this ROOR is an initiator. It is producing radical. What is the radical formula? RO dot. So 2 RO dot will be produced. That is the initiation, and it is done by initiator. Okay. So now this RO dot can abstract one hydrogen, because here you cannot show like Br dot plus H dot, because H dot has got no stability. Okay, H dot has got no stability. Br dot may be produced, but not H dot. That's why you cannot show it that H dot Br dot is happening. It's not happening. So how it is happening then? First RO dot is formed, which is the radical initiator. After that, it is abstracting one hydrogen from here, producing ROH and Br dot. So you are getting Br dot now. After this step, this Br dot getting added. Either it can add here or it can add here. Two possibilities. If it add up here, then what you get? Primary radical. Because the radical dot will be formed at the carbon number 1. Okay. So it is becoming a primary radical, carbon number 1. But if I go for the another alternative one, the bromine is getting added here. Bromine is radical or atom getting added here. Normally, what is the difference between radical and atom? We are using both the terms. That's what I'm telling. Atom means a molecule like chlorine, bromine getting broken into two different atoms. Like that is atomization. But radical usually a bunch of atoms. That is called radical. A bunch of atoms together. That is like CH3 dot. This is a radical. Okay, but that is normally in organic chemistry we call it free radical. On the other hand, in inorganic we are having other radicals also, like sulfate is a radical. Okay, it is an anionic radical. CH3 plus is a radical. This is cationic radical. So that is also there. Cationic radical, anionic radical, and some neutral radical. These neutral radicals are very much active, and they are produced only in a very high energy state. How? Photochemical reaction, sunlight exposure, where high energy is available, ultraviolet radiation. Ultraviolet is very high energy. So high energy state only these radicals are generated. They are called free radical. They are neutral and very much active. That's why this free radical is called reactive intermediate. The name is there already, reactive intermediate. Okay. What are reactive intermediates? Carbocation, carbanion and free radical. These are called reactive intermediates. They are highly reactive. That's why we call them reactive intermediates. Now what is happening here? In the initiation step, we are getting RO dot. RO dot is accepting one hydrogen, producing Br dot. Atomic state. This bromine can be getting added here or added here. If it is added here, we are getting primary radical. If it is added in the terminal carbon, we are getting secondary radical, which is more stable. So obviously it is supposed to be added here. So bromine will be added here, you are getting secondary radical. This radical will abstract one hydrogen from another molecule of HBr. And you are getting the final product, this. This is the final product. Okay? And by that process, you are generating another Br dot. So the reaction will proceed now further. Again Br dot is available. So it will attack another molecule, producing another radical. That radical will extract one proton, producing another Br dot. So that way the reaction will propagate. That's why it is called propagation. First initiation, then propagation. Okay, I can show you if required. So first of all, two molecules, this ROOR producing two RO dot. That is the called initiation. Now HBr plus RO dot producing ROH plus Br dot. Now this Br dot, you have a alkene like this plus Br dot, Br dot producing this. By the way, Br should be added here because in that case the radical will be generated here. On the other hand, if you are adding this bromine here, if you are adding bromine over here, then radical will be generated here, which is primary. So that's why this will not be done and this will be done. Why? Because secondary radical is more stable compared to primary radical. And why it is so? Because of hyperconjugation. That's why already I taught you first the inductive hyperconjugation resonance. These are applied everywhere. Okay, so here is like, how can I explain that this one is more stable and this one is less stable? That can be explained only with the help of hyperconjugation. This is hyperconjugation. So this is
শুভজিৎ দাসকে লাগবে
কে সুজিত দাস কেন
অ্যাপ্লিকেশন লেখানো আছে ইভেন্টের জন্য
আচ্ছা কিসের এত ইভেন্ট হচ্ছে পড়াশোনা বাদ দিয়ে তাহলে ক্লাসে ঢোকার দরকার ছিল না
হ্যাঁ
ক্লাসে ঢোকার তো দরকার ছিল না ক্লাস ডিস্টার্ব হয় না
থ্যাংক ইউ স্যার
এই এটা কি ফোর্সফুল মানে জোর করে করাচ্ছে না নাম দিয়ে দিচ্ছি এটা বন্ধ করতে হবে আমার ডাউট হলো সেই জন্য বলুন ঠিক আছে আজকে যাও দেখছি আচ্ছা Markovnikov product an anti-Markovnikov product the mechanism I have shown you this is anti-Markovnikov product okay this anti-Markovnikov product occurs by three steps first initiation then propagation the next step what is happening that will be repeated again and again and again repeated until and unless one is consumed either HBr will be consumed or alkene will be consumed either HBr will be consumed or alkene will be consumed so this will be this out of the two will be consumed and constantly the reaction will proceed further it is called propagation so initiation propagation and followed by termination yes termination is end how it will be ended obviously one of the reactant must be consumed completely maybe the alkene is consumed either or the HBr is get consumed if one of them is consumed reaction must stop so that is called termination in that case what will be the termination mechanism either the radical generated this radical generated that will can accept another bromine atom available in the vicinity somewhere so it is accepting one bromine over here so that will end up both the radical Br dot is also ended up and this is also getting ended up so both are closed I mean to say it is closed right so otherwise bromine again can recombine producing Br2 and the third option this radical combine R dot combine give you 2R so these three possibilities are there and that is called termination sometimes it must end everything has got some ending so this is the ending okay so these three steps are there in the mechanism and radical is formed, and that's why anti-marconic product is formed. And what is the condition? Condition are heat or sunlight, ultraviolet radiation will be the promoting some atmosphere. Along with that, you have some free radical generator, that is called initiator, and there will be some non-polar solvent. Okay, and if you have polar solvent, then it will obviously go by Markovnikov this process. This is the Markovnikov way. That is the way. So next is mechanism. So this is the mechanism. As I told you already, I have shown you the mechanism, but here it is also there. Protonation to the double bond. First H is getting added. This is Markovnikov is showing. Here it is Markovnikov is shown. So first this double bond is broken, producing Br minus. Here bromide is produced. Then that Br minus is getting added up, producing the brominated product. Okay, so this is Markovnikov. But Markovnikov you cannot see here. The effect cannot be seen here because it is symmetric. If it the double bonded symmetric molecule is seen, molecule is taken, then only the effect of Markovnikov and anti-Markovnikov will be visible. Otherwise, not, it will not be visible. Cannot see the effect because it is both way. Whether it is added this side or that side does not matter. No? Get the same product. Now anti-Markovnikov, see the mechanism. This ROR getting to RO dot plus HBr equal to ROH plus Br dot. Now this you are getting this radical here, secondary radical, then H is accepted from another molecule of HBr, producing Br dot once again. So propagation goes on again and again. Then termination by radical coupling plus disproportionation. What is disproportionation? Radical coupling already told you. What is disproportionation? Along with that, another thing may happen. One molecule is becoming the alkene, other molecule is becoming the alkene. That means one proton is transferred from one molecule to the another molecule. So double bond is formed. Okay, alkene plus alkene is formed from this radical. Two molecule of this radical you take. One molecule is donating one hydrogen to the other molecule. So that way, one will be double bonded compound, other one will be saturated. Means one alkane and one alkene. So the product will be R dash CH2 CH2Br, one molecule. Another will be R dash CH double bond CH Br. Got it? Two different more products will be formed. That is called disproportionation. So this is the mechanism of bromine addition. First Br, you are telling no how Br plus is possible. Yes, here you can see this. Br minus is going out from the Br2. So what you get? Br plus. So this Br plus is attached to this double bonded compound alkene. So you are getting a bromonium bridge. This is called bromonium bridge. The plus charge is generated into the whole region. This carbon and bromine all are sharing some plus charge. None of them is bearing the full charge, but all of them are bearing partial charge. Because this charge, plus charge, is distributed into three atoms. One is bromine, other two are carbon. Okay, that's why we are getting bromonium bridge. And Br minus is here. Now this Br minus can attack either to this carbon or to this carbon, getting two different products. We are getting two different products. This product will be, in one case, you will find the bromine this side and this bromine is this side. Otherwise, if attack occurs here, this bromine will open, this Br plus will open up. So we get another product. And these two products will be mirror images of each other. They are not same, looking same, but they will be different. They are mirror images of each other. Now sometimes mirror images of the molecule can be identical and sometimes not identical. If the mirror images are identical, we call them symmetric molecule. If the mirror image is identical, it will be called symmetric molecule. And if the mirror image is not identical, it will be asymmetric molecule. That means chiral. It will be optically active. And if it is symmetric, there will be no chirality, so optically inactive. Okay, so that's the way you can understand that this particular molecule, if it is suppose alkene and cis 2-butene or trans 2-butene type of molecule, practically you find this one DL pair, another will be mesoisomer. In one case you are getting mesoisomer, in another case you are getting DL pair. DL pair means 50-50 racemic product. 50-50 racemic product is called DL pair. One molecule is 50 D, another molecule is L, and they are always formed 50-50, equal quantity D and L product, mixture, that is formed. That is one. Other one, if I take, then it will give mesoisomer. And if you get mesoisomer, then there is no DL product, because the product itself is optically inactive. DL means optically active, na? But if you get the mesoisomer, it will be optically inactive, because there is a plane of symmetry of the molecule. Okay, now this is another addition reaction. HBr addition we have discussed already. Bromine addition we have discussed. Br2 means bromine addition. Earlier one was Markovnikov, anti-Markovnikov, it was HBr addition. Now after that bromine addition, there is stereochemistry involved in that reaction. Now we are going for another one. This is called hydroboration reaction. Hydroboration, that means with the help of BH3 borane, it is called borane, and it is not stable, so it is always in a dimer form, which is called diborane, B2H6. BH3 whole 2, B2H6. It is called diborane. Have you heard this molecule? Diborane, B2H6. Anyway, so this B2H6 is a electron deficient molecule which can take up electron. Like here there is a double bond means pi electron. Pi electron can be donated to the vacant orbital of boron. Why? Because boron has 3 bonds here, 3 hydrogen, 3 bonds. So how many total electron surrounding boron? Sextate, 6 electrons. So it is called sextate. So in this sextate condition, that means there is deficiency of electron, because all molecule always try to get octet. All atoms will need to get octet. So but it is not getting the octet. It is getting only sextate. So that means there is a deficiency here. Gap is there, some deficiency there. That is called vacant orbital. So it is vacant orbital available here. P orbital of boron is vacant. So that will accept that pi electron from here. So getting attached. After that, this OH minus will attack from the other side, getting this product. So you are getting this alcohol as a product. This reaction is called hydroboration. So BH3 is acting as a catalyst over here. You are getting hydroboration reaction, giving and the product is alcohol. So alkene to alcohol direct you are getting with the help of this reagent, BH3 and H2 to NaOH. H2 to NaOH means actually some alkaline, a few drops of NaOH added into hydrogen peroxide, and then the hydrolysis will occur. Okay. So this
why from BH3 whole 2?
no, actually BH3 is here we are showing BH3 to minimize the complication of the reaction, to show it simply, but practically if you have BH3 it will be dimerized most, yes, B2H6. Why? Because boron itself is not stable. Sextate state is not very stable, unstable. That's why it is reactive. Whenever unstable it reacts. That is the natural rule. Unstable reacts. So BH3 is not so stable, so it is reacting. So in between this BH3, if they react, they are producing something called banana bond. Yes. What is that banana bond? I'll tell you. There are 2 center and boron center and hydrogen. Hydrogen, boron and boron. 3 atom, 3C2E. 3 center, 2 electron. 3 center, 2 electron bond. Boron, hydrogen, hydrogen, boron. How many electrons present? 2. That's why it is called 3C2E bond. 3C2E, 3 center, 2 electron bond. That is the dimer. These three become dimer, giving you this 3C2E, 3C2E bond. And why it is happening? See, I can make you understand this way. Suppose you have less quantity of something, some food or something like that, but you are ready to share. So they are sharing like that. So always does not mean that there will be a pair of electrons shared by both. So here there is a 3 your member and only available electron 2. So 3 are sharing these 2 electrons. That type of bonds are found in other cases also. This is one of the examples. So this is also sharing, covalent bond. But sharing does not mean always will be a pair of electrons shared by both. Maybe 3 partner there sharing 2 electrons. So here see the BH3, how the mechanism is there. What is the mechanism of this hydroboration? See here, this is BH3 and this is your double bonded molecule. Double bond, what is alkene, olefine. This alkane or olefine making a cyclic structure temporarily making a cyclic structure, and you are getting this, and there here this way also you can show, and finally this is the product. And then after that aqueous NaOH H2O2 when you add this particular BHHH, this particular thing will break up producing OH, giving OH. This OH is coming from H2O2. NaOH H2O2 from that mixture is coming out. There is also a mechanism how it is happening. See, this OH minus can attack at the vacant orbital boron, because this boron also has a vacant orbital. And then after that this BC bond is broken by another OH minus. Okay, so that's why it can be opened up. This hydrolysis taking place. This is one mechanism, addition of water to alkene, and this happens by concentrated sulfuric acid 170 degrees centigrade. We are getting what at high temperature. If you alcohol to alkene, we are getting sulfuric acid and alcohol. If you heat at a temperature 170 degrees centigrade, more than 120, double bond will be formed. Now, on the other hand, it is just opposite one. If you take alkene and water with some acid, so then hydration will take place. Opposite. Alcohol to alkene if possible. Why not alkene to alcohol? This is alkene to alcohol happening. Again it is acid catalyzed reaction. First of all, if you give sulfuric acid to alkene, it will give some adduct. You know the term adduct? ADDUCT, adduct. That is means it is an addition product called adduct. Just joined up. Addition product. But it is not a final product. It is a temporary, no, not so intermediate. You can capture it, keep it frozen. You can keep it frozen. Unless you allow other reaction to proceed, it will be in that state only. Like it is called ethyl hydrogen sulfate. Ethyl hydrogen sulfate. Sulfuric acid with ethylene formed ethyl hydrogen sulfate, which is an adduct. Okay? Not very stable, neither very unstable. In between state. But here, unless you give some other thing, like water and all, no further reaction will take place. So you can consider it as a product. But then you have to add water, hydrolyze and get more stable product, that is alcohol. So sulfuric acid with this H3O plus coming from acid. Otherwise we cannot get H3O plus, we get H2O. This H2O plus is formed is acidified water. So protonation takes place, first step, and the second step water is getting attacking over this carbocation, giving you alcohol. That means it is acid catalyzed addition reaction, addition of water, hydration reaction. Markovnikov addition reaction using this mercury as a mercuric acetate, it is called. OAC means what? OCOCH3, that is OCOCH3 is called acetate. In short we are writing OAC. Okay, so this OAC whole 2 means OCOCH3 whole twice. Mercuric salt of acetic acid. So mercuric acetate. Okay, this is the mercuric acetate. That is, what is the role? It is a catalyst. Mercuric acetate is a very good catalyst for hydration reaction. Okay, instead of sulfuric acid, we are using mercury acetate. That is also a salt. Now followed by NaBH4, giving you major as this product. অ্যানো হবে না, যেটা বেশি স্টেবল সেটাই হচ্ছে অ্যাকচুয়ালি দেখো হাউ ইট ইজ হ্যাপেনিং, জাস্ট ইউ থিঙ্ক ওভার হাউ ইট ইজ হ্যাপেনিং. This double bond is opening and getting attacking this mercury also has a vacant orbital. So at the vacant orbital of mercury, this double bond is getting attached. Double bond is, so you are getting a bond Hg with carbon mercury bond, and after that the water is opening this bond. That's why at the same position the OH is getting attached. So there is no scope of rearrangement because you are not producing any carbocation. If you produce carbocation, if it can produce carbocation, then rearrangement is very common. But here this type of carbocation is not formed. Okay, and that's why there is no possibility of rearrangement because this mercury is getting attached here, which is opening only when water is attacking there. So no carbocation. That's why no rearrangement. If carbocation, there is rearrangement. If no carbocation, no rearrangement. Carbocation is not forming, that's why rearrangement could not be made possible. So here this mercury is getting attached, there is a carbon mercury bond temporarily. After that OH is attacking here and this mercury is going out. So as if it is after attachment, someone is coming and it is allowing the first one to go out from the same position. So that's why the carbocation is not formed and there is no scope of any rearrangement. This is the mechanism. You see what is happening. Mercury bond, yes, mercury bond. So mercury carbon, this is a bridge. Mercurium ion bridge. It is best can be shown like a bridge. And after that it will open up like this. And we are getting this Marconi product. See the mechanism. You can understand yourself. Okay, this is the mechanism. HOCl or HOBr addition, Marconi again. Example, more examples of Marconi addition. H2SO4 addition. OSO3H. Yes, regarding this I was telling. Okay, what is the name called? Benzene, this is called, it's an adduct actually. This adduct is formed. Alkyl hydrogen sulfate. Alkyl hydrogen sulfate. This whole thing, if you consider alkene, then, what is H2SO4 is sulfuric acid. What is HSO4 means? Bisulfate, right? So, bisulfate. So, bisulfate also we call sometimes hydrogen sulfate. Yes, because HSO4, so H is there, no? So bisulfate or hydrogen sulfate. So here alkyl hydrogen sulfate, that term is used. This is